As of 2021, Puget Sound is home to nearly 4.3 million people. Population growth has resulted in a variety of negative impacts on Puget Sound ecosystems, including an influx of carbon emissions in the past century. The surplus of carbon dioxide in our atmosphere has led to an increase in ocean acidity because the water absorbs dissolved carbon dioxide, which alters its chemical makeup. Slight changes in these water systems have the potential to be catastrophic.
We share this home with an abundance of marine life, including the staples of the Pacific Northwest, salmon and orcas, both of which add cultural, economic, and recreational value to this region. Orcas have drawn in tourists from all over the world, boosting our local economy. They also help keep ecosystems balanced and serve as an important symbol to indigenous communities throughout Puget Sound. Salmon also offer key benefits, from cultural significance to economic value from the fishing industry and hatcheries. Ocean acidification has not yet been shown to have lethal impacts on local megafauna, but when following their food chain, we can see that their survival is dependent on zooplankton, species that have been known to demonstrate low survivability rates when introduced to pH-related stress.
Our research is looking at planktonic snails called pteropods, or more specifically the species Limacina helicina, because of their susceptibility to changes in ocean pH levels.
Most studies that have been previously conducted have taken place in a lab with manipulated variables.
We want to see what's actually happening to pteropods throughout the Puget Sound in areas with changing pH levels to understand how they respond to acidification stress in their natural environments.
Our goal is to observe pteropods in 3 regions in Puget Sound that each have distinctly different levels of dissolved carbon dioxide, which is an indicator of pH variability. We will use a CO2 probe to measure the dissolved carbon dioxide, and a conductivity temperature depth device, or a CDT, will be used to measure additional variables like temperature and pH. After measuring these variables, we will catch the pteropods by towing planktonic nets. We'll be collecting samples during the summer because that's when pteropods are most abundant in Puget Sound. Because of nutrient cycling in the area, vital nutrients that support pteropod populations will be more available during the summer. We will also be pulling our samples at night because pteropods exhibit vertical migration patterns, meaning that they surface at night and travel down in the water column during the day to avoid predators. Pteropods will be examined using a scanning electron microscope and evaluated based on an already developed cumulative stress scale. By analyzing the shells, we can determine the state of dissolution, which ranges from type 1 being minor, type 2 being moderate, and type 3 meaning severe.
Higher dissolved carbon dioxide levels decrease the concentration of carbonate ions in the water. Because pteropod shells are made of calcium carbonate, the lower the concentration of carbonate, the more likely their shells are to dissolve back into the seawater, which means the shells will have a higher shell dissolution state.
We hypothesize that in Puget Sound, samples of pteropods taken at locations with high dissolved carbon dioxide will have greater shell dissolution than pteropods in areas with lower levels, because higher levels of dissolved carbon dioxide will make it difficult for pteropods to maintain their shells.
After analyzing our data, we would know that our hypothesis has been supported if we find a correlation between high levels of dissolved carbon dioxide and pteropods with a majority of moderate to severe dissolution. If we come to find that there is no correlation between the dissolution type and dissolved carbon dioxide levels, then our hypothesis would not be supported.
There haven't been many observational studies done that are similar to this, so even if we don't find anything significant, this data will still provide us with baseline information for future experimental or observational studies.
However, if we do prove a correlation between high dissolved carbon dioxide levels and high shell dissolution, this information can be used to mediate the effects of ocean acidification on food chains in Puget Sound.
The data we collect can also be used to model the effects of increasing dissolved carbon dioxide in other ecosystems.